So from the last part of this, we determined that all of the possible zeros would be 3, -3, 1, -1, and all of these would be divided by either 2 or 1. Based on all the factors of 3 and all the factors of 2, your constant term and your leading coefficient. I'm going to start with 1 to see what happens. So I get 2. And on the first try, I find 1 0 already. Is one of them. I found one of them already. So this one is a 0. So now I'm going to check the other ones with this expression, because if it's a 0 of one of the original one, it's going to be 0 of the reduced one that we get after using the first 0. So rather than use the whole thing, I'm just going to use this. So that one didn't work. So now I got to pick a different one. So I'm going to pick -3. And after that, I've already found 2 of them. One of them is 1, the other one is -3. Now, if you see here, we have now a constant term and a linear term. This is all that's left. And if we want to find the 0 of this, it's already up here. We don't even need to test anything. This is the remaining 0. But we could put a fraction in and test it. But we don't have to, because we know what it is reduced to after we picked the first 2. So we have the 3 zeros. We have 1, we have -3, and our final one is 1/2. So now I need to talk about something when it comes to non-rational zeros. When you have complex numbers that are zeros, you have to be aware that when you have a complex 0, anytime you have a complex 0, its conjugate is also a 0. Okay? Its conjugate is also a 0. So we have 3 zeros here, but notice one's written twice. That's just a repeated 0. So when we count this, just know that that's included twice for a reason. That's 2 of the 4 zeros, because it's a 4th degree polynomial that we're trying to find. So if we have this as a 0, this is a complex number. Therefore, because 3i is a 0, -3i is a 0. Okay, because one is a 0, the other one has to be as well. So we have our 4 zeros. Now, when I talked about this earlier, I talked about the fact that we have 4 possible solutions. I'm going to write these as linear factors. So I'm going to write this. I'm going to move this to the other side. I get x plus 1. I'm going to do the same thing for this one. For this one, it's going to be x minus 3i. And the next one is going to be x plus 3i. So we have 4 linear factors for this 4th degree polynomial. So if I do some multiplication, for this first 2, I'm going to get x squared plus 2x plus 1. If I multiply this all together, since you're multiplying something by a conjugate, you only have to multiply the first time the last. So I get x squared. 3i times a -3i is minus 9i squared. And I squared is -1, remember, so this is the same thing as a positive 9. So to do some more multiplication, I'm going to multiply this all through. I get x cubed plus 9x squared. X to the 4th plus 9x squared plus 2x cubed plus 18x plus x squared plus 9. So if I combine like terms, I have x to the fourth plus 2x cubed plus 10x squared plus 18x plus 9. And there is my polynomial, and if I set that equal to 0, those are my 4 zeros. So now we have another problem, and this is going to require a little bit of work, but we know one of the zeros. So we know one of the zeros. Okay? So we're trying to find all the zeros if this is a 0. If we're going to try and find rational zeros, we'd have to list all the factors of 60 divided by 1. And all of them divided by -1. So that would take a long time to test. So what we're going to do is we're going to see if we can make this any faster. We know that this is a 0. So because that's 0, 1 minus 3i has to be a 0. So these are my first 2 zeros. If it's a 4th degree, I got to find 2 more. Well, to start with, I'm going to just move everything to one side. So this one right here becomes this. This other one becomes this expression. And I know that if I multiply it by one last thing and set it equal to 0, or excuse me, if I multiply it by one last thing, I would get something similar to this. But I'm not going to do that just yet. So I'm going to leave this blank because I need to simplify this. So this is a lot of multiplication. So I get x squared minus x minus 3i times x. Negative x plus 1 plus 3i plus 3ix, or 3i times x, minus 3i minus 9i squared. So this reduces, since we have a minus 3ix and a positive 3ix and a plus and minus 3i, this reduces to a plus 9 because I squared is -1. My answer right now is x squared minus 2x plus 10. So right now, what we have is an expression that if we multiplied it by something, we don't know what that is yet, we're going to get this. In algebra, if you're multiplying something by an unknown to get some answer, the way you find that unknown is you divide. We can't use synthetic division for this, so I have to use long division. So I have to go through the process of long dividing this. Now, you're going to see this as a squared here. This should be a 3. So I'm going to take this whole thing and I'm going to divide it by this expression. Okay, so I'm going to divide by that whole expression. So I'm going to get some of this work out of the way. So what I have left is a division problem. So x squared divided into x to the fourth goes in x squared times. If this becomes x to the fourth, becomes a minus 2x cubed plus 10x squared. I'm going to subtract all of this. So I get negative x cubed minus 4x. I'm going to drop down the next term, which is a plus 2x. I'm going to divide this x squared into negative x cubed to get a negative x. This becomes a negative x cubed plus 2x squared minus 10x. And I'm going to subtract all of this again to get negative 6x squared plus 12x. I'm going to carry down the next term, which is a negative 60. Kind of ran out of room there. But if I divide x squared into negative 6x squared, I get a negative 6. And if I times this all together, I will get the exact same thing. And if I subtract that all, I'll get a remainder of 0, which is very nice because this tells us that this divides evenly, so we did the math right for the zeros. So now we have to find the zeros of this. And this is a lot easier to deal with because this is probably something we can find very quickly. Now I'm running out of room here. But this is a factorable expression. It's going to be minus 3 and a plus 2. So my last two zeros are 3 and negative 2. So after all that work, we have the zeros of 1 plus or minus 3i, 3, and negative 2. So the last problem that we're going to look at, and I'm going to start it and then I'm going to finish it in the next video, is how you write things as a product of linear factors and list all the zeros. So what we need to do is we need to find out, well, we aren't given any zeros, so we need to find out what the possibilities are. Well, it's the factors of 8 over the factors of 1. So we are going to have 5 different zeros. So I'm going to have 5 different linear factors. So the ones that I have to test are 8, negative 8, 4, negative 4, 2, negative 2, 1, negative 1. So I'm going to start testing them right now. Notice that I'm missing 1. So I'm going to write 1, 0, 1, 2, negative 12, and 8. Now, this seems like a lot, but when you start to boil down and see which ones we have left, you'll see that it gets to be a lot quicker. So I'm going to try 1. Whoops. Made a quick error there. This becomes 1. I've already found 1, 0. Okay, I already found 1, 0 of this. So 1, 0 is going to be 1. Okay, so now I'm going to try another one. I'm going to try negative 1, but I don't need to try it in the original one. I can try it in the one that I reduced. See what happens. That one wasn't a 0. So that one's no good for us. Now I'm going to try another one. So I'm going to try 2. That one wasn't a 0 either, so I'm going to try negative 2 now. Oh, I found another 0. I found 2 of the zeros already, of the 5. Okay? So, since I found 2 of the zeros, I only have 4 more to test, but in the next video I'm going to show you where to go from this.